Hello, everyone, and welcome to today's session on data lake and data engineering on AWS. Thank you for taking time out and being here today. I would like to introduce today's speaker, Shreya Pal. Shreya is here to talk on what, why, and how of data lakes, importance of different layers within data lake architecture, and also on how to engineer data pipelines on AWS. Shreya is a seasoned architect and thought leader having wealth of experience in building large-scale distributed data system both on-premise as well as on cloud. Shreya has worked with Fortune 500 customers in developing big data strategy and roadmap, provide consulting on enterprise-wide data strategy, and also implement data platforms and AI/ML systems. Please join me in welcoming our speaker, Shreya. Shreya, over to you.
Hey, thanks, Srivachan, for the introduction, and thanks for having me for this interesting session. Good morning and good evening, everyone. So, I'm really excited to have this session because this is one of my very favorite topics. And I'll like to just go through the agenda that we would be covering in the next 1 hour. So today we would be talking on data lakes and we would look at what a data lake is, what a data lake is not, because there are a lot of misconceptions about data lakes and the way people envision data lake. So we would talk about that. The benefits of having data lake on cloud, use cases, some architectural principles. So this will be all about data lakes. And then we will do a deep dive into the engineering pipeline. That is, how do we go about building a data lake? There are multiple layers that we have, so we would look at each of those layers individually and then talk about what are the best practices as well as what are the technologies. So when I say technology, I would be talking about AWS services and some of them which are very, very prominent because AWS has lots of services that they offer for one particular layer or one particular task. Okay, and we would be focusing on the fundamentals because if we know the fundamentals, then it's very, very easy to sprinkle any technology that you want, whether it is AWS, whether it is Azure or GCP. So that's the agenda. Let's get started. Okay. So first of all, what is a data lake? A data lake is nothing but a centralized repository. So we can look at it as a repository where we store our data. Now that data can be of any format. It can be structured, unstructured, semi-structured, and it can be coming out of any kind of source. It can be a data which is coming in a batch mode, it is coming in near real time or real time. There is absolutely no restriction as to what kind of data we can store in a data lake or how we store it in the data lake. One of the most beautiful feature you can say of a data lake is that you really do not have to think what use case you want to implement before you get the data in. So there is no structure that is imposed on your data lake. So any data that you have, you can bring it. But when I say that you don't have to think about a use case when you bring data, that's not 100% true in the sense we should not take it literally. Because if we start bringing data without thinking about the outcome, then the data lake would practically turn into a data swamp. And we have seen that practically while building data lakes. So there has to be a methodical approach, a structured approach. And what a best practice is that you should incrementally build your data lake, which means that I may not, it's a middle path. So you don't really restrict yourself thinking that, I absolutely need to know what is the outcome, what is the use case, then only I bring the data. Nor do you have to think that, I will not think about any use case and just bring in data. So it has to be a middle path where you say that, okay, this is my use case, this is the outcome that I'm trying to achieve. So these are the data sources that I'm going to bring in. Plus, I may bring in some supplementary data as well, which I may need in future. So that's the middle path that is recommended when you actually think about data lakes. Now, what a data lake is not, because when initially, now data lakes have been there for quite some time and multiple years. Actually, it's not a new concept. It all started when James Dixon, who was the then CTO of Pentaho, he had coined this term data lake. And what essentially it meant was just a reservoir or a repository of data where you do not have to think about, having like a restriction on what you can bring. And the whole purpose was to eliminate data silos. We did not want to have silos of data residing in multiple places because then it's difficult to derive any insight where you want to join data from multiple sources. So that's how it started. But then there was a misconception. People started thinking that data lake is synonymous to data warehouse. It is not. It is very, very different from a data warehouse because the way you are processing or storing the data is fundamentally different. In data warehouse or in our RDBMSs of the world, we had to think about the structure first. So it was always schema on write. Before writing any data into the data lake, you had to think what should be the structure, the rows, the columns, the relationships. That was the fundamental thing in data warehouses. But for data lake, it's not, right? So they are not synonymous. Similarly, when data lakes started and people started building data lakes, and then Hadoop came in, there was a phase when people thought that Hadoop is synonymous to data lake. It is not. Because if you look at today's world, we are building data lakes in Azure, in AWS, in GCP, even without using Hadoop. We may use, I mean, we can use Hadoop, we may not use Hadoop. We may just use simply, let's say, S3 to store my data and not use HDFS. So we will talk about all these in detail when we look at each of the layers, but it's important to keep in mind that data lake is not data warehouse synonymous, and it is not synonymous to Hadoop. Now, what are the advantages that data lake offers? And specifically, when I talk about data lake on cloud, the first biggest advantage is single source of truth. Because what we are trying to do, we are trying to eliminate the data silos, bring in everything to a one central storage so that that becomes my single source of truth. Then it is schema on read. As I said, there is no enforcement when you are writing the data in data lake. Only when you want to read the data or you want to draw some inference, that is when you are putting some structure to that data. So there is a lot of flexibility because you are enforcing that structure or schema based on your use case only while you are reading the data. Okay, another very, very important point is decoupling of the storage and compute. So I'll explain how. Okay, if you look at the on-prem systems, so data lakes existed even when we were just, building on-prem systems. We were not building any cloud systems. Even for on-prem, what was happening was, if I, let's say, build a data lake using Hadoop, what would I do? I would take certain physical machines, let's say 10, 20 machines, put them in a cluster, make a Hadoop cluster, and use that as a data lake. Now, what is happening is since you have physical machines that you're using, if you want to scale the storage or you want to scale the compute, what you would do? You would just keep on adding nodes to that cluster. So that means my storage and compute are going hand in hand. I cannot decouple my storage. For example, I need more storage. I'm okay with the compute. But to scale, I had to add a node, a physical node. And that means the storage and compute are coupled tightly together. But if you come to the scenario today where you're building data lakes on cloud, you have that segregation, that flexibility to decouple your storage and compute. We will take an example of it when we talk about processing layer, but essentially what is happening is when you are how you're decoupling is your data store or where you're actually storing the data, maybe let's say S3 in Amazon, and the processing is happening using a EMR or some other processing engine. So both of them are decoupled and you can scale them independently. So that's a very, very big plus for a data lake on cloud. Similarly, you have different processing capabilities now because you have that flexibility or that leverage to think of what kind of processing you want to do and just spin up a processing engine or a processing capability, access the data and shut it down. So you can have bigger clusters set up, you can have smaller just-in-time clusters set up. That's totally up to you and the use case you're trying to realize. So you have that flexibility of having different processing capabilities. The ingestion part is again flexible and quicker because you have so many variety of services that cloud offers to you. You can think of having batch, real time, near real time, any kind of ingestion pattern or ingestion architecture that you want. So that actually gives you a lot of flexibility and it also helps you in doing quicker ingestions because you have real time facilities at a button click. Everything is a managed service here. Then similarly goes for varied data access pattern. Now, when we talk about data access patterns will depend on the user personas. So whoever is accessing the data may have different, mechanisms to access the data, different needs to access the data. And in cloud, you can quickly provision that. Moving on, there are certain other advantages which definitely a cloud setup provides you, like low cost storage, because we all know it's a pay as you go model. So you will utilize whatever you want and you'll pay for that. And even those costs are very, very low. So you are actually saving a lot of money because if you were doing it on prem, you had to actually buy the hardware. There was a lead time, there was a cost, there is a IT personnel who's going to maintain that. You have to do maintenance, upgrade, all of that, which you don't have to do with cloud. So that really saves a lot of money. Then scalability and reliability, of course, because it's on cloud, it is scalable. You can just set up certain rules to scale up when you need. You don't have to think or provision in advance and buy hardware. So that removes a lot of burden from you. Reliability, because all the services are reliable. If you specifically talk about Amazon, it is 99 and 11 durability for certain services, and for others, there are different reliability numbers, but then they are very, very reliable. You can actually do cross region replication and all of that. There are a lot of features. So that gives you extreme reliability. Data security. You can think about data security from multiple facets. So we'll look into data security and all of these into detail when we talk about those layers. But these are all benefits that cloud provides. And one of the features that's very important is future ready. Because if I design or architect my data lake correctly, I'm actually making it future ready because I'm on cloud. If tomorrow I have a new requirement in future, I can quickly establish that ingestion pattern or processing pattern without, investing into too much of money or, thinking about it like months before it happens. So it's practically future ready with just some click of buttons. So all in all, data lakes on cloud is a very promising option, and that is what everybody across the industry has started following. Okay, now since we looked at the benefits, let us look at some of the architectural principles that we should follow while we are designing a data lake. First thing that we have to keep in mind is that it has to be decoupled system. That means my ingestion, my processing, and my consumption, they have to be in somewhat decoupled from each other. You cannot think of making them tightly coupled. The reason being, if they're tightly coupled and I change one thing, it is going to affect the other. So what we will do, we will select the right tool for the right job, right? Depending on, so if I just talk about one of the layers, let's say ingesting data, I need to think about what is my data structure, how am I going to access it, how am I going to ingest it, and depending on that, I would choose the right tool. I would not try to use one tool for doing everything. So that's one of the things to keep in mind: decoupling the systems and using the right tools. Then another important aspect is identifying hot, warm, and cold data. Now, what do I mean by that? When I say hot, warm, and cold, it essentially means there would be certain data that I would be using very, very frequently. Very frequently, whether it is for running my ETL pipeline or for doing analytics, it's frequently used. So that's practically my hot data. Then there is data which is used but not that frequently. So that comes into the category of my warm data. And the third set is cold data, which means that that data I need to keep. Let's say in BFS industry, they have certain norms to keep data for last couple of years. Really, I mean, it should be present. You cannot really remove that data. So those are kind of cold data because they are there for compliance perspective or they are archived somewhere, but they are not actively used. Actively, maybe we are using 1 year's worth of data, rest is all archived. So it's very important to think about those aspects because accordingly, I will decide my storage strategy. And that's how I can get cost advantage. Similarly, what should be looked at is where all can I use managed services or serverless services, because that will help me to offload some of this heavy lifting work, like spinning up clusters, maintenance, and all of that, and I could focus on really the problem at hand, the business logic that I want to implement. So wherever possible, we should be using managed or serverless services. Okay, then we talk about event general design pattern. What does this mean? This means that my data lake can practically store every type of data, and I should not be deleting data. I should be storing the data in as is state. I should be storing, so there are multiple layers of data that you store. The as is data, the process data, the aggregated data, all of that is lying in your data lake, and you are not deleting anything. If there are updates, it's like a journaling. It's that journaling design pattern. If there are updates to your data, you are storing the first version, the next, and the next. So you are practically journaling and storing everything so that tomorrow you can actually go and look at any data that you want. Okay. Then one more important aspect, which actually relates to all of the above principles, is the cost consciousness. If for every company or everybody, cost is an important factor. So when we design our system, we have to identify, like I said, the data types, the way I can use the services, what will optimize my whole setup. So that needs to be kept in mind. So these are very, very fundamental things that we really need to keep in mind while designing the data lake. Okay. Coming to the use cases. Now, I haven't listed any specific use case here for a reason, because we can have multiple use cases that we can realize from a data lake, because we have lots of data that we have brought in and from multiple sources. So we have broken the barrier of data silo. We have all the data at one place. So there is no limit to what use cases I can realize on that data set. So practically, I can build an analytical platform. It's industry agnostic, whether it is BFS, life science, or oil and gas, or anything for that matter. Because any kind of use cases, whether I want to build a recommendation engine, I want to run some analytical queries, I want to connect some BI tools to my data, or I want to run my machine learning models. All of that is possible because I have the data with me. So any kind of such use cases I can actually run on my data lake, and so it's industry agnostic. But one thing which we are seeing, like there's a lot of trend and people are doing, is data monetization, which means since we have the data there, we can actually have a data as a service, or we can have data monetization, which means I have bought in a data set, I have done some processing, I have some aggregated data set, or I have some raw data set, which somebody else is interested in. When I say somebody else, you can think about, like, in your organization, you have data which is there in data lake. You can monetize, or you can publish that data to multiple business groups who are interested based on the securities that you want to apply. So that concept is picking up a lot, and that's possible because you have data in one place. So these are the different types of things that we can do with the data, and any kind of use case that we want to realize. And there are scenarios where people want to create a sandbox kind of an environment, or data scientists really want to have data at a finer grain of like detailed or fine grained data. So that can be provisioned for them. There can be requirements of building dashboards or reporting tools, so we can have a ETL pipeline to go through your data, aggregate it, and give it to the reporting tools or the dashboards. So there are multiple ways of actually connecting to the data lake and realizing your use cases. Okay. So till now, what we have covered is the basics of data lake, like how data lake, what are the best practices, use cases, etc. But now what we are going to do is we are going to deep dive into that data lake and look at the engineering pipeline, the best practices for the layers, and also I would be talking about some of the prominent AWS technologies, because AWS has tons of services that they offer for each of the layers. So we cannot talk about all of them. So we would concentrate on the really prominent ones or what we see in the industry people are using. Okay, so this is like a 1 lakh feet view of a data lake where what you have is you have consumers. Those are your source systems who are producing the data. Then you have an engineering pipeline in between, which actually crunches that data, does all the manipulations that are needed. And then you have producers. These are set of downstreams or users who want access to your data. So this is like a very, very simplistic view of a data lake. Conceptually, this is what is happening. But the whole of the magic is happening in the middle layer, which is the engineering pipeline. Because that is where you are doing the entire heavy lifting of bringing the data, establishing all the design patterns that you want, doing the crunching of the data, and then giving it to producers. So today's focus for us is that engineering pipeline. How do we build that is what we're going to look at. So this is my engineering pipeline. So at a high level, the layers that you would have or how you would go about building a data lake is you would first of all have data ingestion, bringing in the data. Then you would store that data into some storage. You would do a cataloging and search. Now this is important because you need to understand what data is there. That metadata needs to be in place. There would be data processing and analytics. And last but not the least, you would have data security and access setup. That's very important because there would be some PII information. There would be some data which is not supposed to be, exposed to all set of users. So that needs to be kept in mind. Now, these are very high level layers or steps that you perform while building a data lake. So we would look at the technology snapshot for each of these layers, and then we would deep dive into each of these layers one by one. Okay, so this is the technology landscape. Now, for all the layers that I mentioned, it shows you what all services, prominent ones that AWS provides, and people use them heavily. Okay, so it tells you that data ingestion, what do we use, whether it is Snowball or Kinesis, Direct Connect, all of that. So it's a summarization of that. We will look at all of these in detail. Okay, so if you go to data ingestion, now data ingestion is simply ability to ingest multiple types of data. And they may have varying ingestion patterns. Like I said, it can be batch, real time, near real time. How do you want to ingest them? So what are the things that we should keep in mind when we are designing or we are putting an architecture for data ingestion? So certain things that we have to keep in mind are, first of all, what type of data is coming in. That's important. What is the type of data is in, whether it is a structured data, it is unstructured, it is semi-structured, how it is coming. What kind it is coming. Is it an Excel file? Is it a CSV? Is it a JSON? How it is coming? That needs to be taken care of. And because that will tell you how are you going to set up that integration or ingestion architecture. Then you need to know the frequency in which you want to ingest that data. Whether that data is going to be pushed to your S3 or any location, or you're going to pull that data from the source system, because that will help you to understand what tool to use to ingest that data. So these are very, very basic things that we have to first look at: the frequency, the type, uh, uh, the structure of the data, all of that. And then comes certain other things like what should be the optimal size. Because if you ingest data and you're getting, let's say, incremental data every day, which is in few KBs, then it will not be very efficient to store, multiple files in KBs. Because when you actually try reading it or processing it, it will become a performance bottleneck. So ideally, there has to be optimal size. So AWS recommends being 16 MB to 256 MB. So you need to have that optimal size. And if your data is not really coming in that size, it is coming in KBs or so, then you need to think of doing a compaction on that to actually compact those small data sets that are coming into a bigger chunk so that your processing is optimized. So you have to look at the size, you have to look at the compaction. Then the next thing that comes is the file format. Typically, file formats like Parquet and ORC are very good because they are splittable, they are compressed, and they are columnar. So that way, it is much more efficient. So recommended is that even if we get data in JSON or any other format, we typically convert it into Parquet ORC and then keep it. So that file format needs to be kept in mind. Partitioning. Now, this partitioning is important because when we are actually doing queries on this data or we are processing it, partitioning is going to help us a lot in terms of performance. So that strategy also needs to be kept in mind. And definitely the ingestion pattern. Like I said, we need to understand the nature of the data and then decide on the right tool to ingest that data. So these are the things that we have to keep in mind. Now, when I talk about ingestion, there can be multiple scenarios. For example, if somebody wants to create a data lake in cloud, most of the times we have seen that customers would, not really want to re-architect the whole thing. Sometimes they would come and tell that, we want a hybrid kind of a scenario where we have certain, tools, technologies that we are already using. We have paid for the license and we want to continue doing that. Plus, we want to go to cloud. So it's a hybrid kind of an approach. So then our strategy of ingestion or our way of using the tools from Amazon would be different because we have to maintain both the setups, the cloud and the on-premise, and they both have to talk to each other because certain of your sources are, let's say, on-premise, certain data you're bringing to the cloud. But when you ultimately want to provision that data to someone or you want to do analytics, there has to be a mechanism so that both the systems can talk to each other. So there is something called direct connect. It's a least dedicated line and it's a private connection that AWS establishes with your on-premise. So it is faster. You don't have to go via the internet. So it is much faster, it is efficient, and it is secure. So most of the times when people want to do this kind of hybrid setup, they go for a direct connect connection, which connects their on-premise to cloud. That way, they are using some things which are there already in their on-premise and also utilizing the cloud benefits. So that is one option. Another option is storage gateway. Now, storage gateway is like a software appliance which you install at your end and you can use it for storing and communicating with cloud. So both of these services are very useful when you want to have a hybrid kind of a setup. Then second type of setup can be where you want to have a migration use case because there would be a lot of data that the customer already has on premise. And if he wants to really shift to cloud altogether, there is no hybrid setup, they want to shift to cloud. Then in that case, there may be terabytes of data that they really want to migrate to cloud. That's like a historical load. And then you would build a pipeline to bring in everyday incremental load and populate your data lake. But for that migration to happen, there are multiple things that we can do. One is that Amazon offers a Snow family of products, which is like Snowball, Snow Mobile, Snow Cone. There are multiple of them. What it does is it's a device, a hardware entire box that is shipped to the customer's location when they request for it. The data can be put in into that Snowball device and then shipped back to Amazon. So that way you are not transferring terabytes of data over the internet. So that's one option. Another option that is there is data migration service. Now this is important when you talk about moving your data from your existing RDBMS to the cloud storage. So DMS, what it will do is it will help you to transfer your data from on-prem to cloud very easily. It is a managed service for data migration. Similarly, there is a schema conversion tool because you may have a lot of stored procs, etc., already written, and there is a schema which is there where in your on-prem that you want to migrate. So that time the schema conversion tool really helps. And there are other services like data sync. So all in all, there are dedicated services which can help you in this entire historical load or migration of your data from on-prem to cloud, and also for the hybrid setup. Now, these are the two cases that I spoke about are for like either historical migration or a hybrid. But generally, when you talk about establishing your everyday ETL pipeline, then there would be scenarios that you have to look at whether your source system is a batch system or a real time. So if it is a batch system, there are multiple ways to ingest that data. You have Axway MFT, which is a third party which can help you to bring in the files into S3, or you can have AWS Glue do that job for you. You can have Spark programs that you write, but if you want to do real time, then you have to have a different set of tool to do that, and that is the tool which is the Kinesis family that AWS provides. So when I say Kinesis family, there are multiple Kinesis services like Kinesis Extreme, Firehose. So depending on your need, you would choose that to ingest real-time data. Similarly, there is a managed service for Kafka as well. So either you go for Kinesis or you go for Kafka for doing the real-time ingestion. So that's how you take care of your data ingestion, the considerations and the AWS tools. Now, this is just one example of real time that I've put here, which shows that if you have data sources and you want to do a real time ingestion, as well as you want to do certain processing while you're ingesting that data, then you would use Firehose, Kinesis Firehose. If you just want to stream in real time data, you can go for Kinesis Stream. But if you want to do transformation, so what you can do is you can use Firehose, transform the data on the fly, and put it into a S3 bucket. That is how people realize the real-time use cases. So you can keep your as-is data as a backup in an S3 bucket and the transform data in another bucket. Now moving on to the next layer, which is data storage. Now data storage is critical because that is where you are storing all of your data. So you need to think of a very optimum solution of where to store your data. If we look at Amazon use cases, most of the times people use S3 very heavily because S3 is very cheap. It has a lot of good features built in, and it helps you in storing your data in any format that you want. It's an object-oriented store, and most of the time people for data lakes are using S3, and they store their raw, aggregated, process all of the data into S3. And when actually they want to do certain queries, they would have other things like Ethna or Redshift Spectrum and all of that, which will just query the data which is already lying in S3. So we will look into those. Now, what we need to think of when we are storing the data. First of all, we need to think about the access pattern, because depending on that, I would choose what kind of data storage I want. Whether my access pattern is that I want the data to be, I want to run a SQL query, a very complicated one on that data which is stored there, or I just want to provision certain data sets to a third party or let's say I want to give access to that data to some data scientist. What's my access pattern? Is there a requirement for caching or not? Because I may store all of my data in S3, but I may have data which is frequently used. Do I want to use caching? That needs to be thought of. Do I need versioning? Do I have to explicitly, because if I'm choosing a tool like S3, I know that versioning is given by default. I mean, there is a feature in S3, you can enable versioning. So do I use S3, or if I'm using DynamoDB, do I have a feature of versioning or not? So all of these factors are going to determine what storage you're going to use. So whether you need caching, you need versioning, do you need high availability? Is the data very critical for you where you really need high availability? You need to do certain cross-region, replication of your data, because these are going to come at a cost. So you will decide which data storage you want to use and what part of data do you really want to make highly available. You have to look at the cost that you're incurring to store that data. Based on that also you would select the service that you want. So these things have to be kept in mind. Also, you have to keep in mind what kind of data am I storing. If my data is such that it has to maintain relationships or linkage, then I would go for a graph database like Neptune, which AWS gives. Or if it is a key value kind of a data that I want to store, I can go with DynamoDB. If I want to use very heavy SQL heavy operations I want to do, I would store my last layer or the aggregated data or the data on which I actually want to run those queries in Redshift. So those are the decisions I make based on my requirement. If I talk about S3 specifically, because S3 is heavily used across the industry for data lakes, so I would just zoom in a bit into S3 features. So there are certain features in S3 which are very, very useful. For example, S3 has a concept of storage class. So you can actually define what data goes into where, because the different storage classes come with different cost. So if we look at this, this will give a brief overview of what storage classes are there. And there is a concept called intelligent tiering in S3, which means that Amazon has a ML algorithm running in the background to judge your data access patterns. And it figures out that if there is a data which is frequently getting used, then you can actually keep it in your frequent access tier, which is it's a storage class, frequent access tier. The cost would be a little higher. If the data is not getting used for, let's say, 30 days, then that data moves to the infrequent access tier. If it is not getting used for 90 days, it will be moved to the archive access tier. If it is further not getting used, like some data which is very old but has to be kept just for compliance, that can be moved to deep archive. So the intelligent tiering is intelligent enough to decide based on the pattern and move the data. So that will significantly reduce your cost, even though S3 is cheap. But if you move it to archive and all, it is going to get more cheaper. So you can actually store lots of data spanning to multiple years. So that's a very beautiful feature that Amazon has given us by default. Uh, Default doesn't we need to enable it, but once we enable, Amazon takes care of moving the data sets across these tiers. So that's one feature. Then you also this entire life cycle management is done by the intelligent tiering. There are also features like tagging. So you can tag your data, you can add prefixes that will help you to actually group your data into a group. So if you tag the data, you can have queries running for those specific tag data. You can actually move the tag data from across multiple tiers. You can set security rules on those tag data. So it practically gives you a lot more control on your data by grouping it together. So these are some of the very, very beautiful features that Amazon gives out of the box that you can just enable and use, which come with a extra cost, but then those costs are not very high. So similarly, there are other options like elastic block storage. So when you take EC2 machines from Amazon, you can attach or increase the storage by attaching elastic block storage. There are also relational database services like Microsoft SQL Server, MySQL, Oracle that you can use as a service from Amazon. There is also a elastic file system. This is just like an NFS. So if you have multiple EC2 machines that want to access one shared location, you can use an elastic file system. So depending on your need, you can choose out of that whole bouquet of storage option that Amazon gives. Similarly, where there is a caching requirement, you can use Elastic Cache. That's also a service given by Amazon. If you want to design a content delivery network kind of a situation like Netflix has, right? They have to deliver content on multiple locations. So typically you can use CloudFront. It is very, very efficient in terms of delivering content to specific geographical locations, and then you can have accelerated transfers across S3 and your CloudFront machines. So all in all, there are multiple services that you can take advantage of to store your data for your different use cases. You can even divide your data, some to reside in Redshift, some to be in S3, and all of that. That juggling can be done based on the use case. Now coming to the catalog and search. Now catalog and search, sometimes it is ignored, but then this is a very important thing because you need to keep track of your metadata. What data is residing in your system. If you have that metadata, it helps you in data discovery. It helps you in cataloging your data and in realizing the use cases like data monetization, where you really need to know what data is there so that you can govern it better and you can actually use that data across your business units or across your organization. So what you need to think of is how do I capture this metadata? Do I use out of the box tool, or do I do it myself by writing certain Lambda functions and triggering them as and when data lands into your S3? How do you want to capture that? There are other tools, like sometimes people use TIPCO EBX, sometimes people use Glue to catalog and store that data, or you write your own to do it. But this is essential. How do you govern it? How do you maintain it? That data has to be indexed so that it is searchable and quickly it can be searched using Elasticsearch or something. It has to be searchable, and we can provide API access to that catalog so that we can use that if we want to provision our data as a service or we want to monetize it. So the technology that is available from Amazon is AWS Glue. It has its own catalog. It has crawlers that can run on your S3, collect the metadata and store it in the catalog. And then many services like Redshift, Athena, they can all use that catalog to query your S3 data. You can use Elasticsearch for searching. You can also use RDS or DynamoDB to store your metadata. In that case, you can have something like this built, which is what you are building as a custom code to catalog your information. You're pulling the data into S3 from multiple sources. So S3 is your practically raw layer. You can have your Lambda functions written on an event. So as and when the data lands, the Lambda function triggers. It captures the metadata, puts it into DynamoDB, puts it into Elasticsearch for searching capability. So that way you are creating an exhaustive catalog of your metadata. Or you use AWS Glue, which already comes with these features. Okay. Now, this is one of the crux of the whole ETL pipeline, processing and analytics. So when we talk about processing and analytics, these are services or tools that we are using to clean our data, transform and aggregate our data. And this is the major work that we do in any ETL pipeline. So what are the considerations that should be taken care of when we look at the tools to choose for this processing and analytics? So first of all, of course, use case plays a very important role. What you're trying to do, that is important. But things that you have to keep in mind is what is the SLA? There would be an SLA to provision the data. So based on that, I would choose how I'm processing my data, what tools am I using? Do I really need to process them in real time, or a batch kind of a process is, sufficient? How many times in a day do I have to do it, schedule it? That needs to be taken care of. Then, to save cost, I can think about in-place querying or transient processing capability, which means that I do not have to have a cluster which is running all the time to process the data. I may just decide to have a EMR cluster which spins up, does the processing, the whole ETL, and then it shuts down. So that's a transient processing capability, and that is very important because you're saving a lot of cost here. Your cluster is not up and running the whole time. Also, you can have variety of such processing clusters spin up. Some can be just in time for certain use cases or doing the ETL once a day, twice a day. Some requirements can be where you need a cluster always up and running. In that case, you can provision one. So you can have variety of processing capabilities, but we need to think through the use case and then think about what to use. We can have in-place querying. Now, in-place querying means I really don't have to spin up a EMR cluster every time. What I can do is I can use Athena. Athena is a serverless service provided by Amazon which can query your S3 data. It can also pick up entire metadata information from Glue. So Athena can be run to run interactive queries that you have. You don't have to have any kind of cluster setup. It's like a in-place query. Similarly, we can have Redshift Spectrum that can have access data from S3. You can use that whenever you want to query data which is already lying in S3. You don't have to have very huge clusters in Redshift where you store your entire data into Redshift. You can just store, like, let's say the last layer or the aggregated data in Redshift. Rest all can be in S3. Whenever you need, use Redshift Spectrum to just query it by creating tables on S3. So that's the in-place querying. For processing, as I said, we can use Glue, we can use EMR, we can put our data in Redshift and run queries, all that is possible. Then another important aspect in processing is scheduling, because not all our jobs are going to be ad hoc. There would be, the ETLs typically would have a schedule. So we can use scheduling tools, like there is a service which AWS has launched recently, which is a managed workflow for Apache Airflow. So either we can use, have a Airflow server set up by our own, or we just use the MWA, which is the managed Apache Airflow. We can use AWS Batch, which can actually run all your batch jobs and schedule, manage, maintain them. Or we can use Control M. Typically on-prem, a lot of people use Control M. So AWS Marketplace provides Control M, and you can do a BYOL pattern, which is bring your own license. So if you have already a license of Control M, just have Control M purchased from Marketplace along with your license, and you can continue using that. But scheduling is important, so we need to decide on what tool to use for scheduling our jobs. Apart from scheduling, there can be certain jobs which are event triggered. So we can use Lambda functions to actually trigger, let's say the data lands in S3 or DynamoDB, a trigger gets generated and the Lambda function runs and does the processing. That's also possible. That is for event driven kind of a scenario. Then once you have actually chosen your storage, you have done the scheduling, there are two, three more important aspects to look at. Monitoring. Monitoring is very, very important. You can use CloudWatch to monitor. You get a lot of facilities to monitor your memory usage, your CPU usage, and there are tons of parameters that you can monitor. This will help you. Even in CloudWatch, you can actually monitor your billing cycle also. I mean, you can just put a cap on how much you want to bill, and all of that is possible. So monitoring will help you to keep a tight control on what is happening on your cluster and how your processing is going on. So that's important. We have to do a lot of logging. Now there is something called Cloud Trail, which actually keeps a track of what API accesses are going on. That is helpful for auditing. So that can be used. Another thing that has to be kept in mind is restartability. Because when we talk about ETL pipelines, we are doing a lot of processing on data, and then there are multiple layers of data through which this whole pipeline goes through. If something fails in between, what happens? How do we clean up? How do we restart? So that's a very important aspect that should be taken care of. Because in a normal scenario, in a normal world, we would have failures and we would have to think about cleanup and restartability. So that needs to be thought about. So these are some of the tools that are primarily used, but there are many others like for storage, like Aurora DB and many others. And even also you can use Snowflake on AWS. So there are tons of options. These days we are also hearing about multi-model databases like ArangoDB and all, where you can store data in multiple formats. NoSQL format, then in a structured format as a graph. All of that is possible. You have Neptune. So there are a lot many options, but practically for a data lake, most of the time people use S3 and to some sense either Snowflake or Redshift. Okay, now coming on to the access and security. Now this is one of the very, very important things because it's important to secure our data. And when we talk about security, it has to be a 360-degree security, meaning not only do I secure my infrastructure, I need to secure my data, I need to secure my network. All of these put together will give us 360-degree security. And this is important. Apart from these three, there is also a compliance angle. So AWS has a lot of compliance certificates on PCI DSS or HIPAA or GXP. Those are also there, but it's a shared responsibility. When we talk about compliance, it is a shared responsibility between the customer and AWS. So we will look today more on the aspects of infrastructure, data, and network because these are the fundamental pillars. If we understand this and we can secure these three, then most of our job is done. So let's first look at the infrastructure part and then talk about each of these IAM, KMS, and VPC. So when we talk about IAM is Identity Access Management, which means that authentication and authorization both should be taken care of. In an IAM world, you would have users like when you are building a data lake, you would have actual users logging into your AWS account and actually getting access to the data. Plus, there is a major work on the API access because you would not practically go to a UI or a console in AWS to provision your services. Your programs would have API access, and they would be actually accessing the APIs, would be accessing the services and doing all of the heavy lifting for you. So there has to be something which comes in between your APIs and the services to safeguard the data and the access. So that's IAM, the Identity Access Management. What IAM does is you would have principals or users that you create in IAM, and you give them specific access. You define their access control. And the way you do it is, if we just look at this diagram, right, what it does, there is an account, AWS account that you have. You need to have certain principals created. Now, principal is nothing but a user or a role or an application. Whoever is going to access anything on AWS is a principal. That person has to be authenticated, saying that, okay, if it is Shreya, does she really have access to access this AWS account? Does she have access to access DynamoDB or S3 or any service for that matter? So first thing that comes into play is authentication. How is the authentication done? The authentication is done by you creating your users and roles, and you define your policies. Okay, so authentication is one. Second is you have to have policies to do authorization. The authorization can be at a service level, where I say that this particular principal has access to the entire service, like to S3 to do all operations. Or I do it at a resource basis. So I say this person has authorization to access S3 and do a get operation or a put operation on a specific bucket. So these are fine-grained authorization that we are assigning. So we would create a policy and we would assign that policy to that. So we can have users, we can have roles, and then we can have policies. So that way I'm ensuring that my authentication and authorization is strictly controlled. That's the role of IAM. And it is also looking at operation level. So you can give at service level, you can give permissions at resource level, you can give permissions at actions level, whether I can create, I can delete, I can list. What is my permission? Okay, so this is what is getting controlled by IAM. Now, if we have done the authentication, we have done the authorization. Now we are talking about data. How do I encrypt my data? Because the data is lying in, let's say, S3 or DynamoDB or Redshift, but I don't want people to have access to that data. I want to encrypt my data. Encryption can be done when the data is at rest or when the data is in motion. When I talk about encryption, that is when KMS comes into picture. KMS is for your management of keys. You can have your server side encryption where, so let's say you have an S3 bucket and you want to encrypt the data which is lying in that S3 bucket. So there are multiple options to do it. Either you enable a server-side encryption. Server-side encryption where the key is getting generated, the data is getting encrypted and decrypted with that key. But the key is generated and managed by S3. The client is not managing it. There can be an option where the key is managed by the client. That is also possible. But what typically we do is when we are keeping objects in S3, we configure the objects, do the configuration for KMS and a server-side encryption so that the objects are encrypted. And when you apply a policy to authenticate and authorize, you also put in an entry to say that the person has access to encrypt and decrypt the data. And that permission has to be given specifically so that a person can have access to S3 to that bucket and to decrypt the data while reading. So all of these key management can be done using KMS. Now we have secured our infrastructure, we have secured our data by encrypting it. Now what else do we need? We need a private network to be set up within AWS, because earlier a lot of people had this concern that AWS is a public cloud. What about security? How do we manage security? Is it safe to put our data in public cloud? There were a lot of concerns, but there is absolutely no issue in putting the data, because there are a lot of security uh, rules or fences that have been put in into AWS. One of them is a VPC. VPC is a virtual private cloud. So it's a virtual private cloud within AWS cloud for your organization, for your need. So you can create VPCs and put all your machines, all your services inside the access to the services very secure by going through the VPC. And you can choose whether you want to enable internet access or not. So if you look at this, typically a VPC is nothing but you are securing your entire perimeter by building a virtual private network. So in AWS, there are concepts of region and availability zones. Regions are nothing but geographical regions like EU West and all of that, right? Asia Pacific, Seoul. In India, we have data center in Bombay. So there are regions. So region is your Virginia or Bombay or Seoul. That's the region. And within each region, there are multiple data centers, which are actually called availability zones. So when you create a VPC, you choose a region and you choose the region which is nearest to you. That will be efficient in terms of cost. So you will choose a region, you will create a VPC, you will give an IP address which will tell how far is your VPC spanning. So your VPC can span across multiple data centers and availability zones. This is done for high availability and resilience. So you would have a region and you would have a VPC which spans across availability zones. All your instances are inside that VPC, so all of them are secure. Your instances can have security groups where you can specifically specify what ports do you want to open, what protocols do you really want to enable. That level of security you can provide. And you can have multiple VPCs set up with VPC peering, they can talk to each other, which is again a very dedicated, secure connection between VPCs. You can choose to have within the VPC, there are subnets that you choose. So you can have private subnets, public subnets, and you can provision this entire security framework within the VPC so that there is further more restriction after even after doing all your authentication, authorization, encryption, all of that. This is again one more fence of security. So that is how you secure your data. And like I said, compliance also, there are a lot of compliance certificates that AWS has, but it's a shared responsibility between the customer and AWS. So all in all, when we look at all of these layers that I spoke about today, these are going to remain the same, whether we use AWS, whether we use Azure, or we use GCP, or we use an on-prem system. The fundamentals or basics of the layers, what to consider while building those layers are going to remain the same. Only thing that is going to change is the technology that we are using. So that's the whole engineering pipeline that I wanted to talk about. And I wanted to give an overview of this whole process and the data lake concept as to how it weaves in with the Amazon technologies, because each of these that we discussed today, each of these layers are a topic in itself. And if you want to deep dive, then there's a lot of services that AWS provides. So I think that's all I wanted to cover on the data lakes.
Thank you, Shreya, and it was really an insightful session, Shreya. Frankly, like what I can see is as you're covering each and every layer, it's not only the text and the slide; it's your experience that is speaking as well. Because something which will not get in documents or theory, because you have implemented so many systems and everything, the experience is highly visible in the talk. Thank you for this wonderful session,
Thank you.
and I see like a lot of questions over there. I'm not sure how much time we have, but let's start answering the question. Maybe we both can answer. I will start with you. The
Sure.
very first question is from Mahesh. Sorry, I just a minute. Yeah, I just put my comment. Yeah, so the Mahesh question is: can a data lake consist of S3, IoT devices sending data to Kinesis, and AWS managed database together?
Yes, yes, Mesh, of course. In fact, that is how we design because so I'll go step by step with all that you have written, okay? When you say a data lake consists of S3, yes, because most of the time we are using S3 as the first entry point to land our data. IoT devices, yes. IoT device is nothing but a source system to me. So there can be multiple types of source system. For IoT devices, will be one more source system to me. I can use Kinesis if I want to do real-time streaming. And of course, I can use managed databases because, see, what I can do is I can either have all of my data, like the raw data, the processed, and all of that into S3. Like we saw that flow using for real-time using Kinesis, that you are putting raw data into one bucket and your transform data into another, right? Or what you can do is you can use the managed database. You can take the RDS service of Amazon, and a lot of people do that specifically when they are used to using RDS services on prem and they move to cloud, they want to use it. Okay, one more thing I would like to say is that when we see people moving to cloud, there are people who actually want to do a lift and shift, and there are people who want to do a re-architecture. So when I say lift and shift, they practically want to use whatever they have been using till now on prem. Okay, in that case, they would like to use RDS or managed databases at AWS, specifically RDS. Okay, and there are people who want to do a re-architecture because they want to move to cloud with a re-architecture. Then they would use the other managed databases that AWS provides, maybe DynamoDB, Aurora DB, or Neptune, anything based on their use cases. So it's very much possible to use all of these technologies together to build that whole pipeline. I think I gave a long answer to your question, but yeah.
No, that's a valid point as well, right, Shreya. Like sometimes, like data lakes, as you said, become synonymous to HDFS or data warehouse. In fact, data warehouse also can be a component of data lake. A data lake is nothing but
Yes.
different storage area catering to consuming applications. Some consuming application may be real time, some may be reporting. Your data lake can be the centralized raw store that is actually doing the heavy lifting and then feeding to your data warehouses and everything. If we start doing like the heavy lifting on Teradata on data warehouse, your cost can increase significantly. So data warehouse, data lakes can actually keep the cost low and make your data warehouse just a consuming application, even for real time. If you want to ingest tons of IoT data, you can use any NoSQL platform on data lake, and you can connect your downstream analytics application on top of it. So it multiple storage layer can play a part in a data lake, right? So that's the beauty of data lake as well.
Yeah.
The next question is from Hamid. Is data processing a consideration for data lake? In my understanding, data lake is just for storage. Processing may be a component of data platform. Correct me if my understanding is correct.
Okay. So when I say data lake, right, data lake is a concept. Now, how do you realize that concept is up to you, what technology you use, what tool you use. But definitely, when I say data lake, it's not just data storage because, see, one part of it is data storage. The concept says that you store all the data that is there into one place. But what would you do after storing that data? You have to do certain processing, or there has to be an outcome. That is where your processing comes into place, and that's where we spoke about that entire engineering pipeline. Because ultimately, you would have your raw data in the data lake and also the process and aggregated data in the data lake. How are you getting to that process and aggregated is through this data processing pipeline. So all of that combined would actually constitute a data lake.
Yeah, that's right, Shreya, right? Next question is from Shakti. How data lake handle or treat structured and unstructured data? Go ahead, Shreya.
Okay. So, see, I would put it this way. Data lake will not differentiate between a structured and unstructured data when you're writing, like I said, right? It's a schema on read. So as let's say an architect, when I'm designing a data lake, I would bring in data of both kinds, structured and unstructured, and then it is up to me to decide how do I want to process or handle that data. So for data lake, it's storing any kind of data, and then you decide what tools and technologies do you want to use to actually process and derive insight from that data. So it can be any kind, and you choose your tools accordingly. But one point I would like to make, when you say unstructured data, right? Ultimately, when you are reading your data, deriving some inference, you are putting some sort of a structure on top of that. It cannot be something which is totally unstructured then, because you're making some sense out of it and categorizing it in some way.
Yes. The next question is from Murali. Is data lake considered a viable option even if you're not dealing with significant daily volume? say not exceeding 1 terabyte annually, but dealing with variants of data from multiple sources. So those are like typically the ETL versus ELT comes into play. Go ahead, Shreya.
Yeah. Okay. I'll say one thing about this. Okay. So typically, when we started our journey, 10 years back, I started working into big data and cloud. That time, people wanted to do big data because they wanted to do big data. Okay. There was no need. I could see clearly that the data was not much. There was no much processing happening. Okay. But still, people wanted to do. But now the situations have changed. I have seen customers also so well aware about what big data is, how to utilize it. And essentially, I would not look at it only from the volume dimension. I would also look at it from the dimension of, having a use case to really bring in all the data together at one place. Looking at maybe use cases which require processing of unstructured data, which requires processing of multi-structured data. Because if you do not use a data lake or a big data system, want to keep using RDBMS, you will not be able to realize certain use cases which are possible with a different set of tools, with distributed systems or with systems which can, process the data. So to answer this, it's not just volume; it can be all the V's of big data. Okay, the variety, the veracity, the use case, all dimensions have to be looked at.
Yeah, and I think the primary dimension is use case, right? If you're specifically using only for capturing the OLTP transactions or something like that, then typically you don't need a data lake. But tomorrow, if you want to scale to different use cases, right? You don't have to see, as we said, the data lake is a concept, right? It need not be S3 at all. You can build a data lake on even any relational kind of, I will not say relational system, but any kind of data warehouses or something as well. The concepts can change, the concepts can be tuned and tailored according to the need. So maybe if your volume is not huge, you don't want to go to the complexity of a distributed data system, then you can use other storage mechanism to achieve data lake as well. That such that it solves your use case purpose. So that is the background of typically data lake. Right? Should okay. Next question is: should a data lake necessarily have only raw data? Is it advisable to perform data quality standardization within data lake or later?
Okay, no, its data lake is not restricted to only raw data. But one important point to consider is when we used to talk about a data warehouse or those kind of setup, right? We would lose some amount of data because we'll enforce a structure on it. We will bring in data. We will lose certain amount of data because we are enforcing a structure and then aggregating and taking it ahead. But in case of data lake, it has this advantage of storing data in any form. So practically, like I said, that event journaling pattern, right? We store everything. We store the raw data also, and we store the other processed, etc. data. And in the data lake, we do all of this. The data quality part of it, we do in the data lake. In most of the cases, we have seen that we bring in data from multiple sources, then we run the data quality, then we go for the data transformations after doing data quality. Now, standardization of data, when we talk about it, so if you're talking about golden records, right? If you mean standardization of creating golden records out of data, then there are dedicated MDM systems to do that. So we should not think that we will, offload the work from all other systems and bring it to data lake. We should use the right system for the right thing to do. So I would say it's a combination. Data lake may do some amount of data standardization, data quality. At the same time, we may use the systems which can do that better.
Right. And a lot of these new age tools like MDM systems and all are typically your data lake or data processing on big data compatible. So rather than the traditional system, they push down your processing of your standardization and everything onto data lake. Now you can do everything by hand, but at the same time you're increasing the complexity, maintenance, and you're making it more like engineering effort. So rather think like what tool fit for your needs so that you're solving your business problem in a rapid way, an accelerated way. How is how it differs for data modeling when it comes to non-structured data, and how it is done when we are joining structured and non-structured data while designing data pipelines. Okay.
Okay. So on the point of data modeling, okay, one more thing that I have seen consistently these days, and it is quite picking up, is people are trying to create a unified data model. When I say unified data model, right? Earlier, if let's say there is an organization and there would be different business units, they would be building their own, so to call projects would be there, where we would be a services company supporting them and building a data lake for them. There would be still multiple data lakes getting built within an organization with different views. Okay, but now what they are wanting to do is they are wanting to have a unified data model. Irrespective of your use case, your entities, if they are common, let's say there is an entity called customer, which is common across multiple views and multiple use cases. They really want to build a data model where there is one single entity called customer, which is like a superset. So a lot of different use cases of different views can actually access that unified data model. And you are not replicating that whole data model at multiple places to create your own use case. So that's one concept that is picking up. Now, coming to your question of joining structural and non-structural, definitely when we talk about such a unified data model or a data model which can support multiple use cases, you need to bring all your data together. Okay, whether that's where I said initially to one of the questions that when we say unstructured, it's not always like purely unstructured. There is some structure in some shape and form that you're putting to it. Sometimes you may put that unstructured data as well in the unified model. Sometimes you may not. You may just have a different path altogether for that unstructured data for a different use case, which may not really require putting it in a structural format, right?
Right. And one more thing, right? Like, see, this unstructured data, typically what we do is we run separate pipelines on unstructured data and derive structural information. Typically, example, take a customer journey. You will have a lot of transaction records on the customer journey, but you will also have customer chat information and other information. Can you derive insights on what are the prominent topics the customer is talking about? Maybe run an NLP model or take like sentiment of the customer, and can that be combined along with your structural information and used in your downstream applications or model? So typically, yes, there may not be a lot of way of joining it, but can you derive information and structure it so that it can be consumed by your downstream use cases and everything? So you can look at that way as well.
Yeah,
So there's a question from Priyadarshi, but Priyadarshi, like there are a lot of migration service providers available, and even like AWS provides it. Like maybe we will answer this offline, because uh, we don't want to like market any company, because uh, we ourselves do it as well. So that's a different story. Okay, so what is S3 tagging? I think like you covered about S3 tagging, right, Shreya? And that's
yeah.
a very nice feature where you want to control your data set access and everything. You want to talk more about it. This from Lucas.
Yeah. So, see, look at it this way. Tagging is like you're logically grouping. You're tagging it, saying that okay, this data is, let's say, let's say tag A. Okay, I want to say that these objects, 10 objects that I've stored in S3 have been tagged as A. What I'm doing is I'm essentially creating a group with those 10 objects because I want to operate on them as a logical unit. Whether I want to give a fine-grained security access or while processing I want to it's like if I compare it to partitioning, right? How do we partition data? We partition the data. Why? Because we want to segregate them as a group and want to access them as that group. That's what tagging is doing for you. It is giving you fine grain capacity to put security, to access them, to manage them. That's the ease that it gives you.
So I think a lot of people have asked, like, will the session be available offline? Yes, it will be available offline. Yeah, as soon as the live session is done, the recording, you can watch it in the channel. All right. Now, Mahesh has an interesting question, right? Deep archive, like Amazon Glacier, right? This has limitation of data access. It could range from minutes to hours. How do we deal with while processing such data? And basically, Glacier is a good storage platform for your regulatory data. Typically, banks have like in some use case, your 20 years of data you need to store, and this data is not used at all. Typically, we just use it when somebody goes to the regulators and complain, and we want to go and do deep analysis on the data. So, what do you think? Like, how we can deal with such like processing delay or processing such data?
So I'll tell you this. on Amazon Glacier, right? Now, Glacier is like Srivatsan said, it's meant for data that is no longer getting frequently used, and that's where I spoke about intelligent tiering also, which finds out what data is not getting used and then keeps on moving it to different tiers. There is an SLA, so if you go to archive, it is like 3 to 5 hours. Deep archive is 12 hours, but what so typically your processing data really doesn't go into that archive because if you use intelligent tiering, it knows it is getting access. And if you do it like move yourself, you know you will not move something to Glacier which you are using. Okay. One more benefit when you use intelligent tiering is if let's say your data is in deep archive and you put in the request to access it, of course it will take 12 hours, whatever is the SLA. But now since you've used it, it moves to your first tier, the frequent access tier. Again, if you keep using it, it will remain there. When you stop using it, it will keep moving to infrequent and then archive. But there is no way to accelerate that 12 hours. That time it is going to take.
Yeah, and I think if the data is going, we want it to be used for processing regularly. Better make sure that it's not sent to Glacier. Um,
Correct.
uh, we know like banking system are highly regulated, healthcare system are highly regulated. We need a lot of historical information which we will not use at all. We use only when a regulator comes and asks for such details. So in those cases, if these are good data that can be sent into Glacier. Let it rest over there. We pay very less money. When we want it, we go and dig it out of it and do our analysis. Right. MWA is too new to be in production. Yeah, that is true, Amit, right? Like any new service that any cloud provider launches, uh, use it with a caution. It's true. Like today they are in a competing environment where they need to keep on launching services. But yes, if we are not comfortable, we can run our custom Airflow engine over there in cloud. Or if we are comfortable, wanting to give it a try, do a POC and use it. So that's about it. Let me go to Chandan's question. For decades, a lot of data has already gone into Oracle or SQL Enterprise DB system. How can the data lake integrate and adopt them for any ML or other purpose need? Just making flat files and upload.
Yeah, see, I think I covered this a bit when I was talking about those hybrid scenarios. So there are a lot of customers who specifically say to us that, we do not want to shift our entire setup to cloud. We want to still have that data. So there are hybrid setups where you have that direct connect that I spoke about, right? So you can utilize the data which is on-prem as well as you can utilize the cloud data. That is one option. But certain people also say that I want to take all of this data that I have today on-prem to cloud totally. Like whether it's lift and shift or re-architect, I want to take that data to cloud. That's where those systems like Snowball and all come into play to make that historical load happen. So either ways it is possible, either the data being on-prem or the data being moved to cloud.
Right. This from Mahesh. This session is really revising my AWS solution architect. Now I'm loving it. And thank you, Shreya, for delivering such a amazing content. We have like few more questions while I am digging for. Can you make a hands-on on data source ML pipeline? Yes, Rajat. Maybe in the future session we will do it. Um, we have plans. Basically, getting content takes time, but over the year, as you can see, a lot of content on all the cloud providers. We are started on GCP. You can go and watch a lot of content on GCP, but AWS will follow. Okay. Again, Shreya, like some great presentation, Shreya, from
Thank you.
India, from AS, really nice. Thank you, Shreya. There are a lot of Sachin has messaged. Great presentation, Shreya. Again, there are a lot and a lot of feedback coming
Thank you.
in.
Thank you.
Can you please include Snowflake and Airflow in your next session? Yes, Shweta, we will try to do Snowflake and Airflow. Uh, we will do a detailed session on that because now we are getting into each and every component of AWS. What we wanted to give a broad architecture overview, broad component overview, and maybe as time comes, we will get into individual components of it. Can this one question from Girija? Can we do batch event triggering rather than triggering for every event in Lambda? Let's take I want to trigger for every 10 or 100 events.
See, that is possible. I don't know whether I should term it as batch event triggering or not, but that's possible. Okay, we can decide how we want to trigger our Lambda function. So See, Lambda can be triggered based on an event, but how do I provision that event? I may trigger it. Let's say there is an S3 bucket where if I drop my data, the event gets triggered. So I will collect a lot of data and then put it into that bucket. That's one crude way of doing it. Okay, when we say batch event triggering, or else we can do. Let's say we are using Kinesis, right? There also we are collecting data in real time. We are doing processing and then putting into an S3 bucket. From there, when it actually goes to the S3 bucket, we can decide what else we want to trigger at that point of time. So it's up to us how do we provision that event triggering.
Right. We can also use typical like Confluent Kafka or
Yeah,
any other system Kinesis, right? So what you do is like you want to trigger out after 10 or 20 events, you control in your application and put a message, and that can maybe there will be a consumer that reads a message and then goes and process it. So the architectures, event triggering architecture or event-based architecture are pretty different ways we can do it. Lambda is one way. There are other ways as well where you can custom create it. This is a message from Krishan. Sorry, I'm sorry for spelling the name wrong. Please explain zone layers in data lake in Azure. So maybe we will do it in generic, not Azure, because it's a AWS session. But the concept is same. You go on premise, you go GCP, or you go as it's same. Landing, staging, curated, analytics as sandbox, and transform. And I am working on a session on Azure specifically, similar to this. So we will cover more details in that. But you want to talk about different layers in a typical data lake, Shreya?
sure. So as I said, right, these layers are basic fundamentals that any typical engineering pipeline would follow. So you would have a raw layer, then you would have, let's say, a layer which is like after the data quality is done, it's a cleansed layer, and then you take it to a transform, then aggregate it. Okay, and there is a separate path which is the sandbox. Now, sandbox is a setup that you are essentially bringing for typically certain use cases where, let's say, the data scientists want a separate sandbox environment and they want a certain set of data to be provisioned there. So all of these layers can be envisioned in any kind of cloud setup, whether AWS or Azure. And typically how people would do it is there are multiple ways to do it. Okay, there is no right or wrong of as to how you do it. One way can be that you keep all your layers within S3 only, whether it is raw or curated or aggregated. Okay, and when you need that data, if let's say on the aggregated data you want to run some SQL, then that is when you use either Redshift Spectrum or you use Athena. Or if you want that your final layer or the aggregated layer or the transform layer that needs a lot of SQL joins, you want to actually push that to Snowflake from S3 or you want to push that to Redshift, that's possible. So that mix and match of what do you really use for which layer is totally up to you based on your use case. Like when I was explaining, right, whether it is key value or it is what kind of data, based on that you decide your storage system.
Right. And you can equate it to Azure, right? Like if you're using blob storage or whatever, you can just equate the same layers to Azure as well. Again, from we'll take few more questions, the couple of more questions. I think like we are running out of time. But again, like a lot of thing, lot of comments pouring in, Shreya, for your tons of thanks, Shreya. Great answer, very insightful session. And then John, great concepts clarified in few sentences. There are questions on like GDPR, CCPA. We need data anonymization, masking. Just wanted to know what method available out of box within AWS to perform anonymization or masking. Go ahead, Shreya. I know there are a lot of vendor product as well that typically integrates well with AWS, but go ahead, Shreya.
See, in the cloud era world, right? When we used to work in the cloud era world, there was something called Red Act, which used to actually help you in masking your data. In AWS, I cannot think on top of my head some service which does masking per se out of the box, but there are a lot of services like there is AWS Macy, there is CloudTrail, which helps you in this way to segregate the PII data, right? So if you look at Macy and all, they help you to segregate, and they're all based on they recognize the pattern and they identify that this is my PII data that needs to be segregated. That is available, but I think masking and all, I'm not too sure. Maybe we need to custom build it to do it in AWS or.
or you can use third party products like
Third
data
party
guys or
products.
any other product, right? Now that's where a concept of data cataloging, which Shreya talked about, comes into play as well. You need to understand each and every column that you have, because when you're talking about GDPR or any kind of PII complaints, you are going at attribute level. And when you go into attribute level, you need to have proper cataloging done on the data with tagging done on the data, so that you can say, okay, how do you want to mask it? You want to do like format preserving masking or any other masking, you can use third party product on any cloud. And typically that's what you want to do, because today we are operating in a hybrid cloud world. You don't want your masking policy one from on premise and one for AWS. You go to a product that is more running on premise as well as on cloud, right? So that's where it comes into play. uh, Shri is asking, if table contains more than 2 TB, how can we process the data? We need to segregate the data into some parts using Attunity to sending data from DB2 to S3, or any other ways we can process the data. Go ahead, Shreya.
See, if the table contains 2 terabyte of data, first of all, we need to look at, are we really processing entire 2 terabytes every time or not? And then definitely partitioning helps, like we spoke about it, right? Even in our RDBMS world, we used to do all of these performance optimization. So we should not be reading the entire 2 terabytes together without any partitioning or bucketing or segregation, because that is going to hit the performance. So definitely the 2 terabyte processing can be done, but internally we need to segregate that either using partitions or something to make it performance efficient. That needs to be done.
Yeah. Sampath, I am sorry, maybe I missed your question. Maybe scrolling down fast, seeing the question, I might have missed it because there are a lot of intermediate comment. But I will check the questions and I'll answer it in my video description, maybe post this session, rather than searching it now. I'm sorry for that, Sampath. Right. I think there are a few questions on, is AWS provided SageMaker other area? It's not free of cost. There are free tier definitely available. You can see if it falls within free tier. I know AWS free tier on SageMaker might not be very attractive to run large jobs, but that is a. But if you want, you can use the GCP, which has a pretty relaxed free tier. They give you $300 and you do whatever it is. Maybe you can check that out. Maybe if you are aware, Shreya, you can add on to it. Maybe is there any better free
No, I don't think so. That would come free, the SageMaker and all. The free tier has lots of free things, like you can spin up micro instances and all of that. But SageMaker, I think we need to pay. But I don't, that's not a very big cost that you would incur, and you can put those like CloudWatch, what do you call, upper slab, saying that the bill should not go more than that, and you can experiment with SageMaker.
tier? I think this is a final question we will take. And again, I'm sorry, like if we are not able to answer all the question, we'll try to take these questions offline and answer it in the video, right? This is a very interesting question that we have got, right? What problem that companies like Databricks are solving, which are not addressed directly in AWS? Can you please explain? The reason is every cloud provider have their own big data service. Your EMR, your Dataproc, they also support Spark, right? So where does Databricks come into play in this architecture? Go ahead, share. Maybe I can answer it after that as well.
Sure. Say Databricks, companies like Databricks, just if you take an example, when Hadoop came in, right? Hadoop, open source Hadoop, you had to go install it, provision the entire cluster, manage it. But then Cloudera came in. What did Cloudera do? Cloudera took Hadoop and they built services around Hadoop and made your life easy to manage Hadoop. So if you look at Databricks, what is Databricks doing? You could have used Spark on your own, just written a Spark program, run it. But what Databricks has done is, it is similarly, it has taken Spark, it has built so many things around it. Now Databricks gives you a very interactive notebook where you can go and write your code. It helps you in merging. So if there are features like, if you have data, incremental data coming in, you need to identify the incremental data, merge it. So it gives you those kind of features out of the box. It can help you in lot more in terms of performance optimization. You do not have to go and look at actually performance tuning a job from the scratch like you do for a Spark program. There are a lot of out of the box features that Databricks provides you to do that. They have concepts of data lake and lake house now, right? So which is mixing this whole data warehouse and data lake together. So all of these things you get out of the box. These kind of optimizations, or you may call added advantages. So it's similar to what Cloudera did to the Hadoop world.
Got it. And other aspect, it right, the reason Databricks and Snowflake and other are still there is a lot of customer do not want to tie themselves out to any cloud, right?
Yes.
If they want to move out of AWS to Azure, they can use Azure Databricks. So there are companies who want to go like completely generic on cloud. It can work anywhere. Now Databricks is nothing but a managed Spark environment plus added other frameworks, right? So you can run the Spark job on premise. You can go and build your CI/CD pipelines on Databricks with slight modification. But if you want to go move to Azure tomorrow, you can just take it and move to Azure. You don't have to do a lot of engineering work. If you're going with EMR, then you have to do some engineering work. Again, the underlying Spark is same, but that is also one aspect that people look at. And to passport, right? I'm sorry, I did not miss your question intentionally. Maybe I was just rushing through. But I'll take this final question. How do we exchange data between AWS and Azure? Uh, Gotcha. Or one thing like, see, the hybrid cloud is picking up, right? The hybrid cloud space is not really matured. People have been talking about hybrid cloud. When we talk about hybrid cloud, it's more like on-premise and your cloud always integrated. But we are not gone completely in. It's possible still, right? We are not got completely into the multi-cloud environment where you have a common security pane, common monitoring pane. It's too far away. Google is slightly matured. The reason is they are back in the market that they are trying to attract Azure and AWS customers. So they need to be mature enough, right? And there are tools like BigQuery Omni, which is in beta still, that can pull data from AWS and possibly Azure and then run it at a single point. Like, what is your thought? How do we exchange data between AWS and Azure, Shreya?
I think this is a space which is still evolving. So if you look at the way Gartner projects it or the trends that are coming up, people do talk about multi-cloud scenario. But to be very honest, I do not. I think it has to be like one use case has to be in one cloud. You cannot span one use case across clouds. In the sense, I cannot say that I have some data in Azure, I have some data in AWS, and I want to join them and build some insights. I don't think that's taking it too far. Ideally, what will happen is you would have certain use cases realized in AWS, and more or less, maybe it will drill down to cost. The comparison of, okay, this particular thing, if I use from Azure, it is cheaper or it provides me more features versus AWS. That kind of a comparison, and people may go for different use cases. But honestly, I haven't really seen that adoption very frequently happening in my experience till now.
Right. And see, the cloud provider are very good when you load data to them. So they give you free data loading and everything. But once you take data out, they charge you for the data egress as well. Right. So the multi-cloud is far off. Maybe it will take couple of years. Some cloud will accelerate faster than other cloud. AWS does not have any need to accelerate on that. The reason is they are leading the market share. Right
Yeah.
now, Google has an intention to get more customers to them. They want, maybe you have data on AWS, okay, use my services which you like, right? So it is a long game, but it's an interesting space as well, right? And yes, the video will be live in the channel post it is complete. I think, Shreya, that's it, right? Like, basically, thank you very much, Shreya. It was a very helpful session, and more sessions like this.
And
And it was really like really insightful, because one is, we can, as I said, right, we can see your experience coming in on building such platform, scalable platform. And definitely there were a lot of users who are asking some interesting question related to it. It was really an insightful session. I know we overran. It was supposed for 1 hour. It's 1.5 hours. Thank you, Shreya, for staying so late. It's almost like 9:30 in the night your time. Thank you for staying so late and being it over here, Shreya. Thank you very much.